Market basket analysis. It is part of what we call affinity analysis. Right? It is part of what we call affinity analysis. The word says a lot about it. It is about identifying items or things that goes together, okay, attributes that goes together. And why do you want to do that? One of the reasons is to ensure that your profitability keeps on being high. How? What do I mean by that? Let's suppose you are an owner of a supermarket, and if you have, let's suppose, different items that are being shelved, you would like to have items that go together to be shelved close to each other. All right. You want items that, for example, if you look at the razor and the shaving cream, these two items might be shelved next to each other so that if someone purchases one, he won't forget about purchasing the other. By doing so, you ensure that people will buy your products without forgetting anything, and this um, keeps your profit on going high. But of course, there are different theories about whether you should place them together or not. But the idea here is to see what are these different products that go together, and from that you can devise strategies to ensure that your products are being sold without any problem. Now, without further ado, let me just get into the idea of what is going to happen when you apply market basket analysis. When you apply market basket analysis, you would have what we call association rules that are going to be developed. And these association rules will always take the form of if antecedent, then consequent. And this will be accompanied by a certain measure that we call a support and a confidence. So the antecedent, if an antecedent, like if I buy razor, then buy shaving cream. If I buy razor, then I buy shaving cream is an example of where the antecedent is the razor and the consequent is the shaving cream. And this will be accompanied by a certain measure to determine how strong that association is, if it's strong or not. Okay. Or you could have another rule. If I buy shaving cream, then buy razor. Please note that these are not the same rule. If I buy razor, then I buy shaving cream. And if I buy shaving cream, then I buy razor. It's not necessarily the same rule, in the sense that you will see later on that the confidence of these two rules are going to be different. But what are these support? What are these confidence? We'll get to that afterward. So I'll get into an example just to show you how it looks like. Okay. A particular supermarket may find that 1,000 customers shopping on a Thursday night. Uh, um, but of the 1,000 shopping on a Thursday night, 200 bought diapers, and of the 200 bought diapers, 50 bought beer. Now, one of the association rules that can be derived from this example would be if by diapers, then by beer. That's an example of an association rule. The antecedent here is diaper and the consequent is beer. And then this will always be accompanied with a measure of how strong the association is. In this example here, there are two measures that are given. One, the support, one, the confidence. The support is 5% and the confidence is 25%. Now, you might ask yourself, but how did I get this support and how did I get this confidence? We'll get to that later on. But just here, the idea is how the rule will have to be developed. It's always going to be if by something, then by something else. All right. So there's always an antecedent and there is a consequent. Now, note that it's not always about buying items. You can develop association rules for other kind of attributes. It's not always about just supermarket items. All right. An example would be if we take the example of a Titanic data set. You see, if a person is in the third class, is it associated with survival or not? So if if a person is in third class, then survive. With what probability? With what strength of this association? So this is an example of here where you don't have items in supermarket, but we are talking about other attributes. Okay, so that's something that is important to know. But you have to understand that if we take, for example, the case of a supermarket, doing applying market basket analysis might be quite tedious at times. Why? Because here, for example, you are talking about 1,000 customers for 2 items. But imagine in a supermarket, you have how many items? 1,000 or more items. Then how do you deal with that? How do you deal with that kind of issue, with that kind of problem? To understand that, let's try to first of all note how many possible association rules you can develop out of a certain number of attributes. Here we go. If you have k attributes, the number of possible association rules that can be developed out of positive cases would be k to power k minus 1. Like if you take the example of let's suppose I take first of all an example of 2 items only. If you have only 2 items, then what's going to happen? It would be if you have only 2 items like the one of diaper and beer, let's try to understand that. It's going to be 2 multiplied by 2 power 2 minus 1, which is going to be equal to 2 multiplied by 2 power 1, which is going to be 4. There are 4 rules that can be developed just out of it. So what are these 4 rules? Like if you buy diaper, let's just confirm what I just said here. If you buy diaper, then buy beer. So one person can buy diaper and no beer. One person can buy diaper and buy beer. Now for the person who buy beer, he may, if a person buy beer, then do not buy diaper. If a person buy beer, then buy diaper. Look at how many possible rules you've got already here. If a person buy diaper, then buy beer. If a person do not buy beer, excuse me. If a person buy diaper, then buy beer. If a person buy beer, then buy diaper. If a person buy beer, excuse me, then buy a diaper. So as you see here, you have to understand though that these 2 rules are not the same here, eh? Because the antecedent for this rule is diaper, whereas the antecedent for this rule is beer. All right. So for this reason, you have to be careful. These are 2 different rules that we are referring to. So in the end here, you see that there are 4 different rules that could have been extracted out of only 2 items. But imagine 1,000 rules, 1,000 items. In a supermarket, you have far more than 1,000, maybe 5,000 items with all kind of products, with all kind of brands, with all kind of things. All right. Here is that in terms of measures and so on. So here, what you see is if you consider, let's suppose 1,000 items, you would have 1,000 times 2 to the power of 999 possibilities. Just understand that this is in terms of millions and millions of possible associations that can be derived. And you would all understand that if you ask a computer to go and identify all these associations and define measures out of them, it's going to be very lengthy process. All right, it's going to be a lengthy process and will take too much time to determine associations. So what do we want? We are not interested in all these 1 million or whatever number of rules. We are interested in only the meaningful rules. And the meaningful rules are going to be the rules that are going to be strong in terms of their association. That is, those rules that would have a relatively high support and confidence. What are support and confidence? We'll get to that afterward. So here, And what we want to do is to apply what we call the a priori algorithm, right? The a priori algorithm. This is used, it is used for mining association rule, as it takes advantage of a structure within the rules themselves to reduce the search problem to a more manageable size. So what is going to happen by applying the a priori algorithm, there are going to be some rules that are weak that's going to be neglected, that are going to be removed from the analysis very early. So we won't be going through all the records one by one. We will reduce our search space. All right, that's the advantage of the a priori algorithm. Now, how does it work? We'll get to that afterward. For the time being, we are just introducing the different concepts. Normally, when we are working with market basket analysis, our data can be in two different formats. One of the format that data can be is, let's suppose, first of all, you have a data that looks like this. Okay, you have data that is in this format here, where you have one item one, transaction one, broccoli, green pepper, etc. But normally, if you have to work this out in a software, sometimes you might have to restructure that data in an appropriate format. One of it is to restructure this data in the form of a transactional ID format, transactional data format. And the transactional data format means in you would have two columns. One would be the transaction ID, the other one would be the items. Like here, the first was broccoli, green pepper, and corn. They all were transaction one. So what happened is that you have the first item broccoli, green pepper, and corn. They are all transaction one. And this goes on like that. That's one way, which is called the transactional data format. There is another way, which is the tabular data format. The tabular data format is here. You would have several columns of data. Each column would represent an attribute or an item, if you want. And out of it, you would have the 0, 1 flag fields as you see here. And these would represent the items. For example, in the first one, we remember there was broccoli, green pepper, and corn. That was our first transaction. So wherever there is broccoli, green pepper, and corn, you would flag it as 1. The rest would be flagged as 0. And this goes on like that. That's two ways of setting up your data. But anyway, sometimes some software may even understand the data. If you get the data into the software, it can understand it in this format. There is no problem, but the processing might be done through this format, for example. Right? The processing will have to be done through this format. So these are the two types, these are the two data formats that you can work with the basket analysis. All right. Normally, us, we will take this format to work with because it's going to be far easier for us to understand what's going on in terms of the number, asparagus, sold, beans, and so on. This is the data that we are going to use as an example in this lecture. Okay. Let's dive in directly into some basics. All right, into some basics in terms of first of all, what are these different things like support, confidence, and let's get back to a recap of what we just said. Normally, you would have an antecedent and you would have a consequent. Now, when I said there would be an antecedent and a consequent, we have to be careful because if I say, suppose if I buy A, then buy B, that's an antecedent and a consequent. But there are cases that you don't have one antecedent rules, but you have two antecedent rules. Like if I buy A and B, then buy C. That's another type of rule that may exist. You also have what we call two antecedent rules. But in any case, you have antecedent, you have a consequent. You have an antecedent, which is a two antecedent rule, and you have a consequent. Now, it is important to understand that these two are mutually exclusive. Like I cannot say if I buy diaper, then buy diaper. that's kind of useless and ridiculous rule that you don't want to have. Obviously, we want to ensure that these two are mutually exclusive. All right, these rules are mutually exclusive. So these are some of the basics that you need to understand. And then the other thing is that we have been talking a lot about the fact that these rules needs to be associated with a measure of how strong this rule is. And there are two that were presented to you, the support and the confidence. I will present to you another one as well, but let's get to this support. What is this support? What does support mean? If you have a rule in this form, if by A then by B, what's going to happen is that the support for that rule would be basically the probability of A and B. As simple as that. It is the number of transactions containing both A and B over the total number of transactions. Let's take the example that we had here. For example, we'll look at broccoli and corn. If buy broccoli, then buy corn. Let's call it like that. Buy broccoli, then buy corn. If I buy broccoli, then buy corn. This is our rule. And what is the support? The support is the probability of B intersection C, as we just learned. What's the probability of B intersection C? How many times B and C goes together out of the whole number of transactions? So the total number of transactions here are 14. And how many times they go together? You have one times. If you keep on going, you will see that there are only two times that they go together. So it is 1 out of 7. You can convert that into a percentage, all right? So you get an idea of what the support is. But there is another term. This is what we call the support. Very easy. Now note something. If I say if by B then by C, the support is 1 out of 7. But if I ask you if by C then by B, that is if by corn then by broccoli, these are two different rules, number one. But their support, I think you would already understand what's going on. C intersection B is going to be 1 out of 7 again, just like this one. The support will not be different, right? The support will be the same, um, but the support will be the same, but the confidence is going to be different. The confidence is what? The confidence, if you are looking at the rule of A then B, if you have a rule that if by A then by B, the confidence is the probability of B given A. That is the number of transactions containing both A and B out of the total number of transactions containing only the consequent, right? So what we are looking for here, the probability of the consequent, not the consequent, excuse me, this is the antecedent. Now, the probability of a consequent given the antecedent. This is what the confidence is, the probability of a consequent given the antecedent. So, if we come here, again, if I'm still interested in, let's suppose, if I buy broccoli, then buy corn. If I buy broccoli, then buy corn, what is the confidence? So the confidence is always the probability of a consequent given the antecedent. So if by B, it means that if I buy broccoli, given I buy broccoli, what's the probability that I buy corn? Get the idea here. Eh? So given I buy broccoli, what's the probability I buy corn? So in other words, the probability of consequent given antecedent. And this is very simple. You need to count how many times people have buy broccoli, and out of this number of times that they bought broccoli, how many bought cones? So let's have a look at how many times you bought broccoli. It's not going to be out of 14 now. It's going to be a reduced sample space. So we have 1, 2, 3, 4, and 5 times that broccoli was bought. So we have the denominator as 5. And how many times out of these 5 cone was bought to get was bought? Cone was bought 1 and then twice. So the confidence is 2 out of 5. Now note something, that if you change the rule as if C then B, that is, if I buy corn, then buy broccoli, already know that the confidence is going to be different. It's not going to be 2 out of 5. Even the support is going to be the same, but the confidence is going to be different because now you're looking at those who buy corn, and then out of those buy corn, how many bought broccoli? So out of those buy corn, how many you've got? 1, 2, 3, 4, 5, 6, 7, and 8. And out of these 8, how many brought broccoli? I think you already see that it is only 2 that brought broccoli. So it is 1 out of 4. So you can convert that into percentage as well. All right. So here you have the confidence that are different as you see for this rule and for this rule. But for this rule and this rule, their support is going to be the same. Okay. So this is a little bit about what we understand by support and what we understand by confidence. Obviously, the higher this value, the higher, sorry, not this value, but the higher this confidence. Let's suppose this probability is 1. That would mean that there is a perfect association between these two rules, these two not rules, but these two items. All right. Just imagine here, for example, the case of broccoli and corn. Just imagine, for example, this one here. Now, if I buy broccoli, then I buy corn. Let's imagine for every time I bought broccoli, there was corn being bought, right? So that would mean that you would have had 5 out of 5, which is equal to 1. But this is a very strong association then, which is good. But it is also important to note that you can't just look at the confidence on its own. It's always important to look at it in terms of a support as well. Because if a confidence is 1, that does not mean anything if the support is too small. Why do I say so? Let's suppose you have you have only one transaction where broccoli and corn was made, right? Only one transaction. The rest are 0 here. All these are 0. Just imagine this was the case. You have a data set where all of these are 0. Now, what would be the support? The support would be 1 out of 14, very small support. But what would be the confidence? The confidence would be how many times out, if I buy broccoli, then I buy corn. How many times I bought broccoli? Out of how many times, if I bought broccoli, I bought corn. It is 1. So the probability of buying a corn given broccoli, for example, in this context is 1 because there is only 1 and there was only 1 corn. So in other words, it's going to be 1. The confidence is 1, but the support is very small. You have to be careful. This kind of rule is not of interest, even though it has a very high association, but it does not bring any interest because it was bought only once. So this is why it's always good to have a look at them together. You can't just look at the confidence on its own because the confidence doesn't mean anything if the support does not accompany it. All right. So you have to look at both of them together. So the idea is if you have a very high confidence but a very high support, then obviously this is a strong rule. But if you have a low support, very low support, but a high confidence, this is also a weak rule, right? So we always need to find this kind of balance to determine from where do we want to have our support. That is, what are the rules that we want to extract out of all these million possible rules that exist. What are those rules that we want to extract? Those rules that satisfy a minimum level of support and a minimum level of confidence. Otherwise, the rest we will disregard. There is another one that we call the lift. The lift is basically a measure of how significant the association is with respect to the assumption of independence, right? If you look at the lift, the formula is given as the confidence or the expected confidence. So if you are talking about by broccoli then by corn, the confidence, as we understood, is the probability of C given B. But what is the expected confidence? The expected confidence is the number of transactions that include the consequent over the total number of transactions. What does this mean? It means we are looking at the probability of the consequent. Here we go. That's what we are saying. If we are saying that the lift is equal to the confidence over the expected confidence, confidence is the probability of C given B that we just discussed, but the expected confidence is just the probability of C. Why am I saying probability of C? Now, imagine that C and B are independent. If C and B are independent, just understand that based on the different former courses, former modules that you had, if these two are independent, one does not impact the other. So the probability of occurrence of one does not have an impact on the probability of occurrence or non-occurrence of the other. All right? So which means that if these two are independent, the probability of C given B is just the probability of C, as we note. Now, in other words, here we are trying to compare how strong the association is by looking at what is the probability that they are associated out of the probability that they are independent. If they are to be independent, if they were to be independent, we would just be looking at the probability of C as if. And then what we want to do then is to now evaluate the probability of C given B. If the probability of C given B is equal to the probability of C, it means that C and B are independent. They are not associated. One does not have an impact on the other, basically. But if this is greater than 1, what would that imply? If this is greater than 1, that is the probability. That is the probability of C given B is higher than, that is the confidence is higher than the expected confidence. Right? The expected confidence here is related to the assumption of independence. Now, if this is higher than this one, what does it mean? It means that the lift ratio, we call that the lift ratio, is, if it is greater than 1, it means that the relationship between the antecedent and the consequent, the relationship between the antecedent and the consequent, is more significant than would be expected if the two sets, the two set means B and C, were to be independent, like here. If this is greater than this, it means that the ratio is going to be greater than 1. So in other words, it means that this association is far more significant than if they were to be independent. However, if it is less than 1, then it's different. It's no more significant, right, than would be expected if the two sets were independent. It's no more significant. The measure here is lower than this measure. So it means that it's not a very significant rule. So we might bypass such type of rule. So we are going to be interested in significant rules, that is the probability such ratio is greater than 1, right? The lift ratio is greater than 1. That is what is of interest to us. We'll take an example and try to apply these different concepts. Okay, here we go. We have an example of a supermarket where there are 10,000 points of sales, right? Out of which 2,000 include both items A and B, and 800 of these include C. It's also known that the total number of transactions for C is 5,000. So our first thing is that we need to understand we are looking at the rule if by A, then by B. That is our rule. Sorry, excuse me. We have a two antecedent rule here. If by A and B, then by C. That's the rule. If by A and B, then by C. Now, we are asked what is the support? The support, as we have understood, is the probability of the antecedent and the consequent. So it's the probability of A intersection B intersection C, probability of A and B and C all together. So the probability of A and B and C all together, how many times these three items occur together? 2,000 times item A and B occurs together. But there are 800 times where item A, B, and C occurs together. If you read it properly, you will see that there are 800 times. So this is 800 out of the total number of transactions, which is which is 10,000 here. So we have a case of 8%. That is, the support is 8%. What is the confidence now? The confidence, as I told you, we are if A and B, then C. The condition is A and B, then C. So in other words, what we want to do, let me just erase that. So the probability of C given A and B, that is what is of interest for us right now. So what is the probability of C given A and B? Out of A and B, how many transactions involves A and B together? There are 2,000 transactions that involves A and B together. So we have denominator as 2,000. What's the numerator? It is how many transactions you have, all of them together. C and A and B. The probability of C intersection A intersection B over the probability of A intersection B. So the probability of A intersection B, instead of talking about in terms of probability, the number of times that they occur, A and B, is 2,000. And the number of times that they occur, C and A and B, instead of probability, C and A and B, is 800. So the confidence here is 800 out of 2000, which is 40%, right? So we are done with this one. What about the lift now? The lift is going to be this confidence that we just determined here, the 40%, divided by the probability of the consequent. What is the probability of a consequent? So let's try to determine the probability of a consequent. So the lift is going to be the expected, is going to be the confidence, which is the 40% that we just computed, divided by what? The consequent. What is the consequent? The probability of C, and how many times the item C has been bought out of all. So we see that the total number of transactions involving C is 5,000 out of 10,000. So 5,000 out of 10,000 is 50%. So in other words, if you look at this, this is smaller than the numerator is smaller than the denominator, which is basically here 0.8. And this means what? It means that the relationship between the antecedent and the consequent, I repeat, the relationship between the antecedent and the consequent is not more significant than would be expected if the two sets were to be independent. I repeat, the relationship between the antecedent and the consequent is not, I repeat, not more, because if this was greater than 1, then it would have been more significant as we explained here. But because it is less than 1, the relationship between the antecedent and the consequent is not more significant than would be expected if the two sets were to be independent. So this kind of rule, we can neglect it. By the way, there is a T missing here. So this kind of rule, we can neglect it because it's not a significant rule. We may bypass such type of rule. All right. So this is a little bit about these different measures that we have. We can look at the support, the confidence, and the lift all together to determine how relevant a rule is. Because remember, as I told you, there are millions of rules that can be extracted sometimes. But we are not interested in all these rules. We are interested in only those rules that satisfy, for example, a minimum support level, a minimum confidence level, or maybe a minimum lift level. Then we need to come up with a strategy that will allow us to consider only those rules that satisfy these minimum level of support, confidence, and lift by reducing our search space through the a priori algorithm. Now, you might ask yourself how this is going to be done, and that's what I'm going to explain now. To be able to understand the concept of a priori algorithm and everything, we have to first of all understand what an item set is and what a frequent item set is. There are two things here. What an item set means, what is also a frequent item set. Okay, an item set if you look at this definition, an item set is a set of items contains in I. What does this mean by contain in I? Let's get back to this. I means the transactions that you have. You have 14 transactions in I. So that is what I refer to as I here. And then an item set is a set of items contained in these set of transactions. And normally you can have different item sets. You can have what we call a k item set. You can have a one item set. And one item set would be, for example, a broccoli. Another one would be corn. And goes on like that. This is an example of a one item set. But you can also have other item sets where you are going to consider a two item set. I'm not referring to antecedent rule here. Please don't misunderstand. It has nothing to do with two antecedent rule, nothing to do about that. We are referring only to item sets. For example, here you can have a two item set where k is equal to 2. An example is bean and squash, or corn and broccoli. Now, a three item set would be some example like this: broccoli, green pepper, and corn. There are different kind of item sets that can be derived. There are several two item sets that can be derived. One example is bean and squash, but just imagine how many possible such item sets you can have from here. Okay, you can have asparagus bean. That's another two item set. You can have bean and squash. That's another two item set, and it goes on like that. So that is what we refer to as an item set. But the item set can be a two item set, can be a three item set, or four item set, things like that. That's one thing. Normally, what is going to happen with that item set is that we can derive rules directly from them. For example, if you consider only this item set here, which is a two item set, bean squash, we can derive a rule from it. We can say if by beans, then by squash. Or if by squash, then by bean. That's already two rules that you can derive out of this. If you consider only, if you consider, for example, this one, broccoli, green pepper, and corn. Here, an example is that you can derive a two antecedent rule. If by broccoli and green pepper, then by corn. Or another rule that you can derive, if by broccoli and corn, then by green pepper. That's another rule that you can define. Or another rule would be if by green pepper and corn, then by broccoli. So just imagine here how many, what is happening here. For example, here you can derive 2, here you can derive 3. So it goes on like this. So depending on the number of item sets, you can define different number of antecedent rules as well. So from a three item set, you can derive a two antecedent rule. From a one item set, you won't be able to define, you won't necessarily come up with a two antecedent rule. From a two item set, you can define a one antecedent rule, but from a two item set, you can define a two antecedent rule. So this is why I told you be careful with what you understand by two antecedent and item sets. All right. So here we can start deriving these different rules from these different item sets. But you have to be careful. Not all of these rules are of interest to us. For example, here, this is an association that might not be of interest because it may happen that the strength of this association is too weak. And if it is too weak, I might not be interested in it. So what is going to happen? We need instead to consider only what we call frequent item set. All right, that is what is of interest to us. We are not interested in all these different item sets, but we are going to be interested in what we call frequent item set. And what is a frequent item set? A frequent item set is an item set that satisfies a certain threshold. Like for example, here, if I define a certain value of phi to be equal to, let's suppose 4, it means that if these items appear at least 4 times together, then I would consider it to be frequent. if we consider the example I was talking about earlier, that is broccoli and corn. If they are, how many times do they appear together? Broccoli and corn. They appear only two times together. So if they appear two times together, it is not four times that they appear together. They do not satisfy that threshold that we just set here as four. So if they do not satisfy the threshold, then they are not going to be considered as a frequent item set. They are not a frequent item set. So we might be interested then to determine what is a frequent item set. Let's take another example. We were referring to, let's take a look at, we were referring to bean and squash. Okay, let's take a look at bean and squash. Is it a frequent item set? Let's have a look at how many times they occur together. One time they occur together. Be careful while looking at that. Two times, three times, four times. Bean and squash, right? Bean and squash. So we have one time they occur together, 1, 2, 3, 4. They already satisfy the threshold already. 5 and 6. So this is, for example, a frequent item set because it satisfies that threshold that we've defined. So beans and squash is an example of a frequent item set, but broccoli and corn is not an example of a frequent item set. Now, you will ask yourself, but what is this value? How do I get this value? This is where it depends on your analysis. I can't come and tell you you need to choose such value or not. This depends on your analysis. All right. It depends on a lot of factors. You might be interested in only very few rules. You are interested in only very few rules. So if you're interested in only very few rules, you might have to set this as a very high value. But if you're interested in many rules, you might have to set this a little bit to a lower value. So it depends a little bit on what is your aim of your analysis and what you want. But you have to understand that if, for example, if you are going to apply the market basket analysis in R, you will not be able to define it as a certain value like this, as an absolute value of equal to 4. You might have to express it in terms of a support. So, for example, this 4, if you understood well, it is looking at the number of times the items goes together. 4 times they appear together. If they appear at least 4 times together, they are going to be considered a frequent item set. But you can look at the same thing in a different way. Instead of looking at it as 4 times together, you can look at it as 4 out of 14 times they occur together, which is 0.2857. All right, that they occur together. 0.2857 that they occur together. In other words, you can look at it as an example of a support of 28.57%. So if your rules satisfy a minimum support of 28.57%, then you consider it as a frequent item set. All right. So the frequent item set is not always necessarily going to be in terms of an absolute value like this. Right. This threshold can be represented in terms of a percentage, like in terms of support. And we will define a set of frequent item set as Fk. So for example, here, this can be considered as F2. It can be part of F2. F2 is bean squash as we just saw. Bean and squash. But then you might have to look at other possible two item sets which are frequent as well, and these will constitute what we call F2. Right? So the set of frequent K item sets. So we are going to look at all the different frequent K item sets. So this is a little bit some notation that you need to understand to be able to get to the concept of what we refer to as a priori. Let's get directly into this concept of a priori property. What is this about? The a priori property here, to be able to understand it, first of all, let's just have a look at what market basket analysis will do. As I said to you, our aim is to determine what are the frequent item sets. Like if you got your F2, it is from the F2 that you will start to derive your different rules. Like as I said to you earlier here, if you've got an F2 as being a squash is part of F2, you can start already deriving your rules. If by bean, then by squash. If by squash, then by bean. That's fine. But for example, for um, broccoli and corn, you can't do that. You can't derive rules for that. Now, but from a yes, from those frequent items, you're going to derive the rules. But the issue is how do you determine these frequent item sets? For the case of a two, there is no issue at all. But when you get to three item sets, if you want to determine, like here, what are these possibilities? What are the rules that have to be derived from a frequent, that will be derived in a frequent free item set? What will be the rules that will be derived in this? This is where the a priori comes in. We are going to reduce our search space somehow to make things a little bit easier. And then, in any case, if you didn't really get it now, we are going to get into an example afterward to understand that better. But understand the property for the time being. The a priori property, what it will do is that if, let's suppose, an item set Z is not frequent. Not frequent means it does not satisfy that threshold that we defined. All right. An item set Z is not frequent. Then adding another item set A to it, like let's imagine you remember beans and broccoli. Was it bean and broccoli? Let me just check it out quickly. It was bean and broccoli and corn, rather. Excuse me. It was broccoli and corn. Let's remember this example of broccoli and corn. Broccoli and corn was not part of F2. It was not part of F2 because it doesn't satisfy this minimum threshold. So it is already not a frequent item set. It is not a frequent item set. Now, if I decide to add asparagus to it, that is, I now look at B, C, and A. That is, I add another item set to it, one item set to it. All right. I add another item A to this item set B, C. I add an item A to that item set B and C. It by default, this one will also not be frequent. If B and C is already not frequent, adding another item to it will not make it frequent. All right, that is the idea. If Z is not frequent, Z union A, that is the superset of Z, will not be frequent. If already this is Z, let's suppose this is Z, adding an item set A here to it will not make this new set, this will not make it frequent. So in other words, what is happening here? We are already bypassing this kind of rules. We are not going to consider this in our search space. We are not even going to worry too much about computing the support or confidence or whatever for these. We're just going to disregard them automatically from our analysis to make our search space smaller. So such type of rule, any rules that's gonna come, anything that you're gonna add to B and C will not make it more frequent. So any rules where there are B and C together, where you are going to add something else to it, will not make the other things frequent, will not make the new set frequent. So in other words, any rules that's gonna be B and C will be disregarded. So that is the idea. I repeat, if Z is not frequent, Z union A will not be frequent. That is the concept of a priori algorithm. And this helps us to reduce our search space in such a way, like imagine here, for example, B and C. Okay, like I told you, you have broccoli and corn. these two are already not frequent. So going to be interested. I'm not going to be interested in the rules bean, broccoli, and cone. I'm not going to be interested in the rules asparagus, broccoli, and cone, or green pepper, broccoli, and cone, squash, broccoli, and cone, and tomato, broccoli, and cone. So, in other words, I'm not going to be interested in deriving any rule. If by broccoli and cone, then by tomato. If by tomato and cone, then by broccoli. I'm not going to be interested in that. If by tomato and cone, then by broccoli. Anything that is with these two sets, I'm not going to be interested. So I'm not going to derive these rules. Imagine how many rules have already been disregarded, making your search space easier and your analysis faster. So that is the idea behind this a priori property. Here we go. So we are going to have a look at how we can apply all these together. All right, we are going to apply these different rules together. We are going to have a look at the same example, that is these this transaction data, and then we are going to start generating rules. The generation of these rules will depend on the frequent item set. So we'll start obviously by the first item set, okay, the frequent one item set. We are going to take again this same threshold that we said as being equal to 5 being equal to 4. And then from that, we are going to start deriving our rules. Let's start talking about the first frequent one item set, that is F1. Now, to start with, what we need to do is to have a look at how many times each of these, for example, asparagus is 1, broccoli is 1, and so on. How many times they occur on their own? Do they appear at least 4 times each and every one on their own? All right. So, for example, if you look at asparagus, how many times they appear? 1, 2, 3, 4, 5, 6. So it's already crossing that threshold. So it will be part of our F1. Brick beans, 1, 2, 3, 4. It's already appearing at least 4. So it continues. So it will appear in our F1. Broccoli also, you will see it appears at least 1. So here in this example, if you look at it, each and every item that you have, 1, 2, 3, 4, 5, 6, 7 items, will appear at least 4 times. So in other words, each one will be part of the F1. That is, each one would be part of our first of our frequent one item set. This asparagus being the 7 will be there. If one of them were not to be frequent, then you would have disregarded it. Let's suppose bean was not there. Let's suppose. Then bean would not be part of F1. Okay, so that's our first. In this example here, all of them are satisfying that threshold, no problem. So we move on next. The next step, now, before we move on, let's suppose we have these frequent item sets. You can start deriving rule from it. Remember that what the idea is that you have to find all frequent item set. Like here, we've got F1. Find all item sets with frequency, we've got our F1. Then from the F1, we are going to generate association rule, satisfying a minimum support and confidence condition, that is satisfying this minimum value here, all right, this minimum value that you got here, minimum support value, and also a confidence condition if you want. So if you get to this one, given that all of each and every one of them is part of F1, you can also start deriving a rule, like if by asparagus, then by nothing. All right, you just leave it blank, then by nothing. That's one example of a rule. If by bean, then by nothing. If by broccoli, then by nothing. So that's an example of a rule that you can define. So, or you can, yes, that's an example of a rule that you can define, where you will see that the support will be basically the number of times that the asparagus appear on its own. All right. And this kind of rule is a case where there is no antecedent. So it's a no antecedent rule. There is, no consequent rule here. But you can also have a no antecedent rule where if by nothing, then by asparagus. If by nothing, then by asparagus. Basically, they are the same thing here. But this is a rule that you can derive. If by nothing, then by asparagus, or if by asparagus, then by nothing. So, but these are not very of interest for us. We are interested in rules that will bring in association, because this one is just a count of how many of these items is appearing. So what is of interest is our F2 at least. Our F2 will start deriving rules. Let's get to F2. To be able to get to F2, one of the things that you will have to do first is to define what we call the candidate to item set. We refer to that as a candidate to item set. Right? Before we derive our F2, we will need to define a candidate to item set. So all the possible to item sets that we have. That is the idea. What are the two possible item sets that we have? All right. And to be able to determine what are these possible two item sets that we have, we can do it by joining F1, Fk minus 1 with itself. What is our interest here? Our interest is to get C2, not F2, not yet F2. We are talking about C2 for the time being. To be able to get C2, it's going to be a list of all these different two item sets. But how do I get these two item sets? An example of a two item set would be asparagus and cone, another one broccoli and cone, and it goes on like that. How do you do that? Is by joining F1 with itself. F1. Why did I say F1? Because f of k minus 1. So what we want to do is to take the different items that you have in F1 and join it with itself. An example would be asparagus bean, asparagus broccoli, asparagus cone, asparagus green pepper, asparagus squash, and asparagus tomato. That's one possibility that we have here. Just imagine asparagus bean, comma, asparagus broccoli, and this goes on. How many possible candidates you have for the two item set? It goes on like that. You can imagine now bean broccoli, bean cone, bean green pepper, and so on, okay, up to the end where you get squash and tomato. So you have all these different possibilities that exist that we are going to show you in a moment how they are. So we are going to define the candidate, the two item sets candidate. Now, but to be able to do that, remember that it has to join the frequent item set, because for us, each of them was frequent here. This is our F1. F1 is about all the 7. If one of it was not there, let's suppose bean was not there, you would not have taken bean. If bean was not part of F1, bean would not have been part of C2. All right. So in other words, you have to be careful. You just don't go back in the data here and then try to figure out all the possibilities, because if bean was not there, C2 would not be containing it. You would not take C2 in there. Right? So it is based on the F1 only. Remember that it is based on all those that were frequent already. And we have a long list of all the possible values. So that's our first step. Then we will move on from that to determine what is Fk. So first of all, let's just have a look. Here we go. We have asparagus bean is one possibility, asparagus broccoli, and it goes on like that. You have a long list of all possible outcomes that we are not writing in the form of sets here, but we are writing it in the form of a table, because this is going to help us later on to understand how to prove our rules later on. So you have all these possibilities, which can consist of a candidate to item sets, the C2. It is now what is going to happen is that we are going to prune C2 based on we are going to prune C2, and then the item set in CK that survive the pruning step will form FK. How do we prune C2? We prune C2 in our example here because C2 has been formed from F1. So, in other words, we are not having an issue where the superset is going to be less frequent. This is not a problem because we are not making C2 out of C1. We are not making C2 out of C1, but we are making C2 out of F1, which is okay. But still, you have to be careful because you have to understand that this does not mean that when you are joining all these two item sets together because they were frequent originally, that does not mean that asparagus and bean will be frequent. That doesn't mean that asparagus and broccoli would be frequent now. So what do we want to do then? We want to prune all these item sets that do not satisfy our threshold, and this is where we come here and have a look at what are the items that satisfy this threshold. So for example, asparagus and bean appears 5 times. How do I know it appears 5 times? Excuse me. Asparagus and bean, they appear 5 times together. 1, 2, 3, 4, and 5. Then you need to do the same thing for asparagus and broccoli, how many times they appear together. So that's what we are doing here. Asparagus bean, 5 times, asparagus broccoli, and it goes on like that. So you already see here that when you look at the frequency of these C2, these are our C2 here, these list, asparagus bean, asparagus broccoli, and so on. You will see that now some of these rules will be pruned. Like if you have asparagus bean is 1, another one is asparagus broccoli, that's another one, and it goes on. So you would see that this one will be here, but this one will be pruned. We'll cut it out. In other words, when you are going to create your F2, our F2 would contain asparagus bean, but would not contain asparagus and broccoli. Right? It would not contain. So this is pruned out, this is pruned out, this is removed, this is kept, removed, removed, and it goes on like that. So we have now a short list of F2. Let's have a look at these F2. Here is our list of F2, our frequent two item sets that are left. We had originally C2 to contain all these possibilities. Here we go. But now we have fewer possibilities because we are looking at F2, which is our frequent two item sets. That is, they pass the minimum threshold criteria. From this F2 now, you can start deriving rules. If by asparagus, then by bean. If by bean, then by asparagus. If by asparagus, then by squash. If by squash, then by asparagus. If by bean, then by corn. If by corn, then by bean. And it goes on like that. You have all the rules that can be developed from that that will satisfy a minimum threshold of 4 that we said earlier. That is, our phi is equal to 4. All right. All these will be at least appearing 4 times, obviously. And they are frequent item sets. They are frequent two item sets. So those rules that we are going to have later on, if I buy asparagus then buy bean, they will have at least a support of 25% that I mentioned to you earlier. All right. So that is, they would have at least a minimum support of 4 out of 30, 4 out of 14%, 14 in terms of percentage. Here we go. We have our two item sets from which one antecedent rule can be developed. All right. We can have a look at the one antecedent rule, by the way. Let me just show you this quickly. Here we go. We have this one antecedent rule. If by asparagus then by bean, the support is 35.5%. And all of these rules that were part of the F2, these were part of F2 here. If by asparagus then by bean, asparagus, and it goes on like that. All of them, you will see that they have a minimum support of 4 out of 14, that is 28.6% that we mentioned earlier. So this is an example of rules that are being defined from our F2, not from C2, but from our F2. All right. So you can also find out the confidence. You can compute them as we explained in the class, as I explained to you earlier. So that's part of the frequent two-item set that we are done. Let's get back to now two antecedent rule. So we have been able to develop a one antecedent rule so far through these, but now we need to move on to find F3. But as I said to you, to be able to find F3, we need to find C3 first. All right. When we found C3, then we can find F3. But this is where things get interesting. We have to obtain these C3. Okay, and how are we going to obtain the C3? To obtain the C3, as the principle says, we are going to join together Fk minus 1. You remember earlier, Fk minus 1. So if you are interested in in C3, you have to join Fk minus 1 together. That is, you have to join F2 together with itself. You have to join F2 with itself. What does it mean by joining F2 with itself? An example would be if by asparagus, if you look at these two, let's take these two only, right? You have asparagus bean and asparagus squash. One way of merging it into C3 would be asparagus, bean, and squash. Another way is asparagus, yes, asparagus, bean, and squash is part of it. Now, if you look at bean, corn, and squash, you can join bean, corn, and squash together. And how do we do that? How do we do this merging? This merging is done in here by looking at this. We join F2 with itself, where item sets are joined if they have the first k minus 1 item in common. All right, let's get back to this slowly and try to understand what's going on. But when I say in common, it's in terms of alphabetical order. All right, it's in terms of alphabetical order that we are going to look at this, so that we don't get lost in the process. Let's get back. We have F2. Our aim is to determine C3. From C3, we will get F3. Now, to be able to get C3 now, we have to join F2 with itself. We have to join F2 with itself. That is, we have to merge these different F2 together, all right? But how do we do this merging of them? How do we merge these together? To merge this F2, now let's look at that. We have to look at the first k minus 1 item. We are talking about F2. What is the first k minus 1 item? 2 minus 1, that is 1. So in other words, the first 1 items, all right, the first 1 item. So what is the first 1 item that is common? And we are going to join them together. For example, here we have asparagus, bean. And then you see again that there is asparagus. So if there is asparagus, bean, asparagus, squash, these two are the first 1 item, that is asparagus and asparagus, are common. So what's going to happen? These two are going to be merged to form our C3. That's the first part of C3 that is going to be merged. Asparagus, bean, and squash. Now let's have a look at this. Asparagus, bean, and corn is the first, as we said here, the first 1 item in common with these two. Or the first 1 item in common. You might have been here, and corn, but you have to always look at the first item. You will see that asparagus is not common with bean here because they are not the same. So if you had asparagus here and you had asparagus corn, you would have merged them. But because the first 1 item, how did we get this 1 item? Based on what I just explained here. From the F2, you need 2 means You need to do 2 minus 1, that is the first. From the first item, the fact that they are not in common, we can't merge these together. You can't say, for example, asparagus, bean, and cone. You can't just put asparagus, bean, and cone here. Right? That doesn't work. Don't put asparagus, bean, and cone. Okay? It won't work. But let's move on. If you see that there is nowhere there is asparagus next, so obviously we move on to the next. We have bean, cone, bean, squash. So what's going to happen now? We have bean, cone, bean, squash. So we see that bean, cone, bean, squash, we can join them together. So we have bean because they are the first one item, because you are talking about a 2-item set here. So the first one item is common, bean, bean. So bean, cone, and squash can be joined together. The next is what? You see that bean, this is done. Now, but you have again bean, bean, tomato. Again, bean comes in common first. So, in other words, you can now join bean, cone, and tomato together. So here we go. But then for broccoli, unfortunately, you won't have anything else. So, in the end, our C3 will consist of 3 elements, which would be what? Which would be asparagus, bean, squash, bean, cone, squash, bean, cone, tomato. All right, bean, cone, tomato, and bean, squash, tomato. So it will consist of these different sets: asparagus, bean, squash, that's one. And then I repeat, bean, cone, squash, right? Bean, cone, tomato, and then bean, squash, tomato. These are the different items that I have in my C3, right? Which is here. Asparagus, bean, squash, bean, cone, squash, bean, I repeat, asparagus, bean, squash, bean, cone, squash, bean, cone, squash, bean, cone, tomato, bean, squash, tomato, bean, cone, tomato, bean, squash, tomato. These are our these different item sets that we have in C3. But what is going to be our F3 now? When we've done with C3, what's going to be our F3? So you have to be very careful and go slowly here so that you don't get confused. So what is our F3? This is where the a priori concept come in. The a priori concept come in. Why? Because it enables us to disregard many of these rules at one go. By looking at those items, as I said earlier, the a priori property says that if Z is not frequent, adding another item set A to it will not make it more frequent. So what does this mean? It means that if, for example, let's split this into 2, all right? If asparagus and bean was not frequent, listen to me well, if asparagus and bean was not frequent, then this whole thing will not be frequent. In other words, I would not have to derive any of the rules regarding these 3. Let's try to see if any 2 possible outcomes, any 2 possibilities here, like asparagus bean, asparagus squash, and bean squash. Let's have a look if any of them were not frequent. If this is the case, then we are going to disregard this rule, any rules that can come from these 3 at one go. So asparagus bean, bean squash, asparagus squash. Asparagus bean, it satisfies the threshold, no problem. We had bean squash, it satisfies the threshold, no problem. And then asparagus squash. So asparagus bean, bean squash, but asparagus squash. Here we go, it satisfies the threshold. So in this example here, all of them satisfy the threshold. So if each one of them, like if you have a Z set means a 2. If you're talking about a 3-item set, the Z would be 2, all right, item set. And then Adding another element would be adding squash to it. Will not make, if asparagus and bean was not frequent, adding squash to it will not be frequent. Or another way of looking at it, if bean and squash was not frequent, adding asparagus to it would not be frequent. So that's what we are referring to here. But for this one, we are not going to prune it. We leave it as it is, but we still need to check if this satisfy the minimum threshold of 4. But we'll do that later on. Let's proceed by step. Let's move on to bean, cone, and squash. What do we need to do now? We need to look at bean, cone, bean, squash, and cone, squash. So if bean and cone were not frequent, the whole thing would be pruned. Let's have a look at bean, cone, and squash. Bean, cone, and squash. Bean, cone, it's okay. Bean, squash, it's okay. Cone and squash now, it's not okay. Cone and squash is not okay. So because cone and squash is not frequent, because it doesn't satisfy our threshold, because cone and squash is not frequent, it's like we are saying Z is not frequent, cone and squash, that is Z is not frequent. Adding bean to it will not make it more frequent. So in other words, what is happening here, this item set is removed. That's how we proceed. So we're already getting rid of one item set. We don't need to go and identify the rules and identify whether the support is satisfied or not. We already know that if you had, this is like telling you, you already know that if you had to look at these, would they occur at least 4 times together? No, they would not have occurred 4 times together. Now bean cone and bean cone, bean tomato, and cone tomato. Okay, bean cone, bean tomato, cone tomatoes. Let's have a look. Bean, cone, and tomato. Bean cone, okay. Cone tomato, okay. Bean tomato. So bean tomato, bean, cone, and tomato. So bean, cone, okay. Bean tomato, okay. Cone tomato, okay. So we are not going to prune it for the time being. We leave it as it is. All right. So this is not going to be pruned. Let's move on to the next. Bean, squash, and tomato. So bean, squash, squash, tomato, and bean, tomato. So bean, squash, tomato. So bean, squash, tomato. Let's have a look. Bean, squash. Okay. Bean, tomato. Bean, tomato. Okay. And squash, tomato. It's 2. Not okay. So in other words, this has to be pruned based on the a priori algorithm. All right. Following the a priori algorithm, these 2 have been pruned. But the next step now is just to count these 2 sets. How many times they occur together? How many times does asparagus, bean, and squash occur together? And how many times does bean, corn, and tomato occur together? All right. So we have just pruned 2 possible item sets using the a priori. Now we need to still confirm which one will be part of F3. Will it be these 2 together, these 2, or will it be only one of them? All right. So what do we do? Let's have a look at asparagus, bean, and squash. Asparagus, bean, and squash, how many times do they occur together? So we are referring to asparagus, bean, and squash. How many times do they occur together? If they occur at least 4 times together, they are going to be part of our F3. 1 here, 2 here, 3 here, and 4 here. At least 4 times they are good. So we have 5 times. So this is going to be already part of our F2. All right, this is going to be part of our F3, excuse me. This is going to be part of our F3. So in other words, this one is all good. We are not going to prune it out. So we already have part of our F3 set already. So asparagus, bean, and squash. What's the next step? Have a look at bean, corn, tomato. Does it satisfy the threshold? Bean, corn, tomato. Bean, corn, and tomatoes. All right. So let's have a look at bean, corn, and tomatoes. So we have 1 times that they occur together, bean, corn, tomato. Do they satisfy the 3 times? So bean, corn, tomato another times occur together. This do not occur together. These do not occur together, but this one occurs together. So we have 3 times that they occur together, but they do not satisfy this threshold that we just said. All right, they do not satisfy this threshold of 4. So we occur only 3 times together. So in other words, what is going to happen here? That's the other rule that is being pruned out. That is, they will not be forming part of F3. So our F3 basically is only one set of 3 item sets, that is asparagus, bean, and squash. That's all. So in other words, from the F3 that you got here, you will see that you can start deriving a 2 antecedent rule. If I buy asparagus and a bean, then buy squash. If I buy asparagus and squash, then buy bean. If I buy bean and squash, then buy asparagus. So you already got 3 rules that can be developed out of this. So in other words, why these 3 rules? Because they are the one that will satisfy our minimum support of 28% that we mentioned earlier. All right. So this is a little bit what I just explained to you here. You can split it into 2 parts as I explained. You will see that you can't go further into this rule. Our rule will stop here, so we can't go any further. So here we have what we call a singleton frequent item set. Singleton because we have only one item frequent item set. Okay, as far as just bean and squash, we don't have more than that. So, but if you add another one, let's suppose, as I said here, the bean, corn, and squash was also part of F3, then you would have derived rule as well for bean. If by bean and corn, then by tomato. If by bean and tomato, then by corn. All right. So, but here you have a singleton frequent item set. So this completes the task of finding the frequent item set. You can't go further. As soon as you leave, you get to a singleton frequent item set. You can't go even further in trying to find out F4. You won't be able to find F4 because remember C4 is obtained by joining F3 with itself, but you will see that later on it won't work. You won't be able to join. There's nothing to join there. All right. You can't, if there is a singleton, you can't join F3 with itself. There is only one F3. How would you join it? There is nothing. So your task stops here. So that's a little bit how association rule is derived, and this is what I just said. You have to derive subsets to be determining which one is frequent or not. We just already did that, but this is just the theory. So we are left with this here, the support and the confidence. You will see that the support again is 28.6. You won't have any support that is lower than that because we have ensured that this is satisfied based on what we explained by taking into account the 4 as minimum threshold. So here we go. We have been able to define our different rules that are strong based on our definition of what we said to be strong. That is the satisfy minimum support of 4%. Now you can go a little bit further and you say, okay, you don't want all rules that have a minimum confidence of you want rules that have a minimum. You want rules that have a minimum of 80 confidence. So if this is the case, then in addition to that, what you will do then is that you would avoid presenting this rule. You will not be presenting this rule. You will be presenting only the first two rules. All right. So these rules that we are saying here, out of all these thousands of possible rules that you might have had, or hundreds of possible rules that you might have had, are those rules that are of relevance because they are the ones that are strong. Imagine, as I said to you here, you had 7 times 2 power 7 minus 1 possible rules that were possible for the case of a two antecedent rule like here. All right, let's take here. So you had 7 times 2 power 7 minus 1 possible rules. But out of all these possible rules that you have, 7 times 2 power 6, which is a big number, you have only those few rules that have been derived. And these few rules are the strong rules that you have. Okay. So the other thing, by the way, sometimes we do is also to present the rules in terms of support times confidence. But the other thing that we also want to do sometimes is we can do it in terms of lift. Like we can try to evaluate the lift by looking at the expected confidence. And then by looking at the expected confidence means by looking at the probability of buying B, you take the confidence divided by the probability of buying B, you get the lift, and it goes on like that. And you see for those who are greater than 1, if they are greater than 1, you keep them. If they are less than 1, you may disregard them. Right? There are different other ways, or you can look at the support and confidence together multiplied. So for example, here you see that this is the strongest rule because it has the highest support time confidence. All right, you can sort it out. You can sort these rules in terms of their support time confidence, or you can sort them out in terms of support itself, or you can sort them out in terms of confidence. It all depends on how you want to sort them out and what is of relevance to you, what is of interest to you. So that's how we get association rules. All right. And as I told you, you can apply it in different contexts. All right. We want to know what products are associated with what products. So that's a little bit what we understand by association rule. What I'm going to do, a I will send you a list of some R codes to be able to apply this rule. All right, be able to apply the association rule on a data set. What data set? On the Titanic data set. So what is going to happen is that not sorry, excuse me here. Yes, we are going to consider the Titanic data set, and I'm going to give you a data set where I want you, the Titanic data set, where I want you to apply the association rules by developing rules with a minimum support of 0.5% and a confidence of 80%. All right. So I want you to derive these for in R. So to be able to do so, I'm going to send you a list of R codes that you can go through on your own. Okay. And if ever you have any query on these R codes, you are most welcome to come back to me and I would advise you accordingly. But you will see that there are rules which are going to be redundant, that will be pruned as well. So we can prune these redundant rules, and this is going to be explained in the R codes as well. So that's all for the case of association rules. Please do not hesitate to revert if you have any query. Thank you.